right, my name is Luis Majano. I'm the CEO of Orto Solutions. My background is in computer and hardware engineering. I was born in El Salvador, in Central America, and I was mostly raised in the US. Since 2023, I'm in Malaga, in Spain, to lead our European division. And I'm the creator and maintainer of many frameworks and the chief language engineer for BoxLang, new programming language. So since you came after lunch, we'll do a little dad joke. My kids always wants me to do a dad joke on my sessions. So what do you call an anxious dinosaur? No takers? A nervous Rex. Dad joke. All right, little agenda. What are we going to show? The goals, what is BoxLang, take you through the semantics of the language, and of course, some of the features and how you guys can get started. This project basically started 21 months ago. It's not something that we wanted to create out of the blue. It has taken a lot of time for us to get here. And we launched our first iteration of a stable version in May of this year in Washington, DC. And we're iterating quite fast as we progress with the language and our customers using BoxLang. So what is BoxLang? Well, in a sentence, BoxLang is a modular dynamic language for the JVM, aiming to make your development more productive, more expressive, functional, highly functional, and really available everywhere. That was where we started. This is what we wanted to build. We wanted to make it small and lightweight and modular. The entire runtime is about 7.58 megabytes. It is multi-runtime. That means it can be deployed, as I'll show you, into many, many different types of systems. It is also multi-parser, so it can actually parse different source codes. It is dynamically typed with an optional and an inferred coercion type system. So at runtime, it can do many, many things to make you more productive. It supports classes, scripting, and we've also built a templating language. It uses everything modern in the JDK, including invoke dynamic to deal with dynamic languages. Highly functional, like I mentioned. You can do context-aware closures or pure lambdas and many other constructs that we've created. Built-in framework concerns, and I'll explain a little bit of what that means. And of course, it's open source and free. So many people ask me, okay, why, right? Why another language? Why create a language? So it's important to know a little bit of who we are and what we've been doing in order to kind of answer that question. So the company that created this is called Orto Solutions. It was founded in Miami, Florida in 2006 with one framework to deal with model view controllers at the time in a language called ColdFusion. So it's been now 19 years that we have been creating professional open source products and a lot of development, right, and many different languages, from Java to Groovy to Rust, Python, etc. And we build a tremendous amount of libraries. We actually manage about 350 open source projects at Ortos, and we've done this for over 19 years. So this was basically a way for us to push forward in order to service our customers and with all the ideas of everything that we wanted to build. This was basically the last step. So we did not really wake up one day and said, hey, we want to create a language. We're a little crazy, but not that crazy, right? It's a lot of work to get to where we were. So it was really mostly the culmination of these 19 years of development. We really needed to innovate the way that we wanted and at the pace that we wanted. And we couldn't do that with any of the language vendors. And we really needed that path forward. So we forged it ourselves. And in reality, dynamic languages on the JVM had not evolved at all. I think the last dynamic language in the JVM was before even 2014. So we really wanted a language of the times. And we even did a write-up of when we started to do this as well. So fast forward, those 21 months of development, we did about 27 beta releases, 3 release candidates. We're now into our 4th minor update. We have a collection of almost 13,000 automated tests. We created a lot of test frameworks, so we wanted to make sure that everything was automated and tested. Over 60 related repositories, a ton of modules and contributors already, and we have only just started, right? And this is a snapshot of the team all over the world that we're working together to bring you BoxLang. So that's a little bit of a history on why and what is BoxLang. But let's delve a little deeper into some of the features and semantics. So first of all, we really wanted this to be multi-runtime. We wanted to go in a lot of places that don't even exist yet. So when we started designing BoxLang, we looked at the lowest way that we could actually execute Java bytecode. And that was embedded systems. So we focused on chips. We focused on making it really fast and really portable. So now you can actually run BoxLang at the lowest level possible. And then afterwards, we started basically building up and innovating and saying, OK, now for CLI applications, how can we build for CLI applications, for including it with current Java applications? That we created a mini server, which is a very lightweight server based on Undertow. And so forth and so forth. We started integrating and creating all these runtimes where developers can deploy their BoxLang applications. And then, of course, the future, which we don't know, right? But we wanted to cement, right, all these architectural decisions so in the future, it could be very easy for us to innovate, okay? Of course, we're creating the world of Docker. So all these Docker containers are also available to you. That's another runtime. We have 3 images available. You have a command box image, which is our servlet interpretation. So we created this over 10 years ago. So we manage our own servlet implementation. A mini server, which is the lightweight Java server, and of course for CLI applications. Okay? So all this is already available. And our first production app on this multi-runtime world was try.boxlang.io. So we really wanted to create a developer space so they could try BoxLang and learn how to work with BoxLang. So when we envisioned it, we said, OK, we want a mini server site that a developer can code in. Then we can send that code into AWS in this case, have a lambda, execute that code in a very isolated BoxLang runtime, process it, and then send the results back. So with the team, we actually sat down, and in one afternoon, we had built both runtimes. So this was a true testament of how multi-runtime actually can affect your development. So it was our first production application that we launched a year and a half ago, powered by 3 of those runtimes, mini server, Docker, and Lambda. You can now do all kinds of things with it, and we're building tons of features into try BoxLang as well. The cool thing about it is its performance. We have an average of about 32,000 Lambda executions per day. Our average execution time is about 32 milliseconds. Okay? And we contract and scale as traffic progresses. And the really good thing is that we pay actually $0. Because Lambda gives you 1 million requests, and we're on the borderline. So very, very impressive thing that you can do with Lambdas, that you can produce very high traffic applications and really pay 0. So what's coming next in multi-runtime? So we've seen the performance of it and how it actually works, that we have many, many plans that we're working on. Azure functions are being built as we speak. So that's the next evolution of multi-runtime. We're also working on JavaFX, so you can actually build desktop applications with BoxLang. So that's something that's already in the works. And our Electron multi-runtime is also available probably in the next 2 weeks or so. And then we're going to integrate with GraalVM as well to bring you even more languages, so you can actually integrate other languages inside of the runtime. So a lot of development going into multi-runtime. Another major aspect of BoxLang is we wanted a modern dynamic language, right? So we wanted to address dynamic typing, but we also wanted optional typing. We wanted to be JSR 223 compliant, which is Java scripting in the JVM. We use invoke dynamic. Everything new in the JVM is being used internally. We actually created a framework called the Dynamic Object Framework that will probably going to be released as a separate thing. And this allows any object, no matter where it comes from, to become dynamic. That means that it can do type promotions, it can do auto-boxing, auto-casting, type coercions, everything out of the box for you. All the OO constructs are available to you as well. 100% Java interop. We wanted Java developers to feel right at home when working with BoxLang. So that means that there is no separation, no bridge. You can import Java classes, you can leverage them, and we've actually extended them, as you'll see in some of these slides. But you can execute BoxLang within Java, or you can execute Java within BoxLang. So you can go either ways, right? We created a concept of object resolvers, because we're actually a mediator between languages. So now you can actually say, I want an object from Java, or I want an object from BoxLang, or anything else. For example, we have one for Python. So you can actually create Java classes that represent Python objects. Right? So you can directly import and create any of these classes. You can call third-party ones. You can create import aliases. So you can actually give an alias to a specific import and say, import Java util.date as JDate. So this will allow you to remove ambiguity. Okay? And of course, you can even import with an @ sign, and you can match it to a specific module, whether it's custom or core. We've also done pure functional programming as well inside of BoxLang. So we have BoxLang BIFs, which I'll cover a bit, which are built-in functions that are globally available and headless. Java static method references are available to you as well. So that's a BIF. I can just say double point use case, and I can reference a global one. Or I can go directly to a Java class and reference their static method references. But I can also pass Java instance methods around, which I can't do in Java. But with BoxLang, with our dynamic object framework, I can take any Java class and any Java method and move it around and actually execute it at a later point in time. I can also do object invokers. So that means that code, like you see there with a map, that you have to do an S and then a closure, I can just basically do a .trim. And the compiler will know that you're wanting to act upon the object that was going to be passed into that function. So there's a lot of shortcuts and things available to make your coding more sugary sweet when you're coding. So that was very important for us. Another important aspect for us is that we did not want to start from zero. We had 19 years of code that we had developed that we wanted to bring into BoxLang. So when we did the design of BoxLang from ground zero, we said we wanted multiple parsers. So we created something called the BLAST. And the BLAST is basically the BoxLang abstract syntax tree. And we wanted this to be the mediator between any type of language that we wanted to encapsulate in BoxLang. So this was a way to split with the old and bring the new. And you can do it just in time or with CLI tools. So for example, we had 19 years of development in the ColdFusion CFML world. So what we did is that any CFML source code will actually compile and parse in BoxLang and run natively. And this is all powered by the BLAST because it has a transpilation layer, just like TypeScript, for example, and it will transpile the code for you. So we actually have requests for COBOL and Groovy as well. And the idea was to open that to the community so anybody can transpile things into the BLAST, which then compiles to Java bytecode. So this powers all of our tooling, and this is a way for legacy and application languages without any code changes to be able to be modernized. And with that, all our 350 libraries that we built actually run in BoxLang with 0 code changes. All right, time to show you some code and a little bit of differences. So semantics. You have 3 avenues to work with BoxLang: classes, scripting, and templating. We have the concept of scopes. This is a little bit different than Java. All variables are going to be stored inside of what we call scopes. And scopes are backed by concurrent maps behind the scenes. So when you say name equals BoxLang, that name variable is going to be created inside of a map internally called variables.name. Okay? Each execution context can have different scopes. For example, scripts have a variable scopes. Functions have an arguments, have a local, and surrounding scopes. Classes can have public, private, static. Threads, we can actually create very easily threads. You have local, attributes, or thread scope. And you have global scopes. So you can store things like, I want a singleton. Well, you don't have to do the singleton pattern. You can just say application.something, and it will store in your application. Or even the server, or the request, or the session. And you can create your own scopes as well. So it gives you that ability for you to be able to say, OK, an argument that comes in, it's inside of a scope, right? Or I can say var, and it goes into the local scope if you wanted to. I can treat the scopes as objects and functional objects. Here I'm looking at all the variable scopes surrounding that function, and I'm filtering it and say, hey, give me a filter, and I only want functions. So a lot of things and a lot of power that you can do with scopes. And inside of classes, of course, you have more scopes available to you. So this is a very big distinction from Java, for example. Apart from that, we've created enhanced types or very specific types apart from all the Java types that you get. And we wanted this to include you with all kinds of member methods and more functionality. So you have functional arrays that can contract and expand very easily, and you can do all kinds of functional programming with them. Okay? Everything can be case insensitive. It doesn't matter what case you use as well. And here in this example, I have a fruits array that I define. I can append one, then I can filter it by item final case. I can print each item and then convert the entire array to JSON. So JSON is native within BoxLang as well as YAML. Okay? You can also then be able to have all kinds of different things like structs, which are basically maps that are case insensitive. We have a query, which is everything that comes from a JDBC driver. You have the ability to have a native query. Datetime objects using the new Java time. Numerics, because BoxLang is typeless, so it will actually navigate through the numerical types according to the mathematical operations that you use. And it's smart enough to determine which mathematical operation and which numeric it's going to contagion into. Okay? And of course, all is autocastable and dynamic and fluent for you. Functions. So functions, you've mostly seen this in other languages, where in BoxLang, for example, all functions are public by default. You don't have to say public. All return types are any by default as well. All arguments are any by default as well. And any is really anything, right? We'll determine that at runtime. However, you can actually do type inference, or you can actually do optional as well. So in this case, I can say, I want to return a numeric, and I'm going to accept 2 numerics. This means it could be an int, it could be a double, it could be a big decimal, it could be a big integer. It'll accept everything. It'll automatically cast them for you, it'll automatically box them for you, and it'll automatically verify them for you. Okay? However, you can also be very specific. So I can say, no, it has to be an int. Okay? So you can either go completely typeless, or you can go completely type. It's your choice. With function arguments, you've seen this mostly, I believe, in Kotlin or Groovy. We follow that same useful pattern where you can have required arguments and optional arguments. Arguments can have default values as well. But in BoxLang, values can not only be literals. In BoxLang, those values can actually be expressions that are going to be evaluated at runtime. So you have those 2 available. So it'll delay the evaluation of the argument until that function is called. And then it'll evaluate the expression. You can also have, by convention, a keyword called argument collection. And you can pass a complete map into the arguments, and it will bind them for you. So this is super easy when you actually don't know which arguments you're expecting, but you're collecting them from forms. So you can actually say, hey, here's an argument collection. Go try to bind them. And it'll try to bind them according to the arguments. Now, like I mentioned about scoping, ooh, that was too fast. Go back, real quick. Just a review, I left this just for documentation, that basically says that in functions, there is no need for you to do any type of var scoping. Everything goes into the local scope of the function. All the variables are inferred. You can mix types if you want. You can actually do struct literals. So if you ever wanted to do a map literal in Java, for example, you really can't. So this, you can actually do a struct literal, as you can see. You can even do an ordered literal. So you can see an ordered map by just using the brackets expression, and that now is an ordered map. Okay? So there's a lot of little sugary things there available to you as a developer, so you don't have to be defining classes and iterating with classes. You can just do literal expressions. Okay? We have the concept of built-in functions, which other languages have as well. There's over 300 of them, all ordered by category, and they're basically available to you as helpers. Okay? They are used for core functions, And the cool thing is that you can actually create or override those global functions via modules. Everything in the language is overridable via modules. And that's important. So in the example here of code, which is a little small, but any of those functions that you don't see defined usually are coming from a headless function. Okay? And there's many of these. And this is where the framework capabilities come. They're not only normal capabilities, but there's a lot of functions to help you deal with other things. There's also the concept of built-in components, and this was inspired by web components. So now we have an entire framework for you to build components that the parser understands, and we create several of them that are created for you, and then you can create your own. You can actually create core ones that are used for the entire runtime, or just in your application by using the underscore. And I'll show you in the next slide the underscore ones. But here, for example, you can see 1, 2, 3, 4 examples. You can see an HTTP call. So we've created an HTTP framework for you to abstract all HTTP calls. You can just say bx:/HTTP, give me the URL, give me a method, a result, then a block, and then you can basically start defining how the HTTP call is going to be defined. And then it'll execute it after you. You can do ones with post data. Here's a thread. That's how easy you create a virtual thread in this case. I just say thread. I want action run is actually, you can remove that. It's by default. But you can just say thread, give it a name, say it's virtual, and then create a block, and everything inside of that block is now a thread. Okay? You can also do zips, right? And all kind of these framework capabilities that are going to be available to you. Now, these are for scripting, for example, but we also have the templating language. So with the templating language, you can also have the same syntax, just surrounding it with the angle brackets. So if you're doing a UI, and you basically want to reuse a template that you built, you can say, hey, I want a new component, which is like a web component. Here's the path to that web component. Here are arguments to the web component. You can surround content within it, and then your component can interact with it. You can also have, by convention, a folder called components or tags, and then you can refer them with the underscore. And that will mean that it's going to look by convention into a folder inside of your application or your deployment package, and it'll look for the alert. So we really wanted to make it very expressive, and this borrows from multiple languages, from CFML, from Blade, from GSP. So you have all these capabilities to do templating and build expressive UIs. Some developer-friendly operators. Null coalesce operator, usually referred to as the Elvis operator, of course, is available to you. So anything on the left-hand side, if it becomes null, then it takes the right-hand side. The cool thing is that it can pat any expression on the left-hand side. Then you also have the safe navigation operator. So anything that is dereferenceable, that could be objects, it could be arrays, it could be structures, it could be anything. Anything that's dereferenceable, you can actually do a safe navigation, and then it will try to say, hey, does that exist? No, and it'll continue if not. So a little bit of sugar to help you as a developer, instead of avoiding doing all kinds of if statements. With casting, we really wanted to make it more user-friendly, especially dealing with a dynamic language. So we're used to doing casting in Java with the parentheses, but we actually introduced the cast-as operator. And with the cast-as operator, it gives us more flexibility because it does the same thing as the Elvis. Everything on the left-hand side is going to be evaluated. So any expression on the left-hand side is going to be evaluated and then casted to the right-hand side. So then you don't have to be dealing with all kinds of parentheses. We do a lot of asynchronous computations in BoxLang, and we wanted to bring a very easy asynchronous framework. So with that, we created unmodifiable variables. So very easily, we have member methods on any type of list or map interface, and you can just say to modifiable or to unmodifiable, and then you can lock that data structure and pass it around. And this goes for anything in Java and anything in BoxLang. String interpolation was also a big one. We wanted to do it like other languages that do it correctly. For example, Confusion in this case. So any expression inside of those hashes is going to be evaluated, and it can be put anywhere. Anywhere that hash expression is going to be evaluated, it's going to be evaluated as an expression. Vue.js also started this trend, and Angular a long time ago, when you had the triple mustaches. So Same deal. Anything within it is an expression. Okay? So if I wanted to actually build JSON, that's how I can build JSON manually. I can just open a string, make it an object literal, ID, title, author, pass in the expressions, and that will become JSON. Closures and lambdas was important for functional programming instead of imperative. Context-aware closures, just like other languages where they are aware of their surroundings, are available. But we also introduced the availability of a pure function, or a lambda. And lambda for us, as a pure function, means that it does not know anything about its surrounding. It only takes arguments in and returns values out. So it's deterministic. So that was important. And you have those two types of expressions available to you. And their functions are first-class citizens. They can be detached. They can be removed. They can be added, etc. You can pass them around. You can define them in line. You can do lots of things with functions. We did a lot of enhancements for classes to make quality of life. So for example, here's a class definition with 3 properties. They're not fields. They're called properties in BoxLang. You can do defaults. You can do annotations on them. And all the automatic constructors are created based on those properties. So you don't have to create constructors. To string, equals, and hash codes are done, of course. Automatic getters and setters are done for you. Automatic implicit invokers are also done. This was inspired by Flex from a long, long time ago. And of course, automatic JSON and YAML conversions. So it'll look at basically all of the properties, and it'll try to marshal them into JSON or YAML. And you can even add annotations of which ones you want, which ones you don't want, which ones you want to map, etc. In this case, in this example, I create a new person. I don't have to create a constructor because it's automatic. And then I can basically just say person.firstname. I don't even have to call the getter. It'll be smart enough to get the getter for you. And then I can say person just to JSON. Give me a JSON representation of yourself. All right, we do also a lot of metaprogramming, inspired by Groovy as well. So there's always a $BX property inside of classes. And this one you can use for meta information, for the class information, but you can also do listeners. So the language is completely event-driven, so now you can register change listeners on any object that exposes a register change listener. So in this case, here's a BX variables or a map, and I can say, hey, I want to listen to any time important data is changed. And it will basically call that closure whenever the important data is set. There's another one at the bottom where basically I'm going to listen to everything inside of that map. Anything changes on this map, I want to know about it. I forgot how much time we have. 20 minutes. Good. All right, templating language. So the templating language, of course, you can use it to build UIs. You mix and match with normal HTML, inspired, like I said before, from Blade, JSP, CFML, and GSP. You can create your own tags very easily. You can import collections of those tags. You can use the global BIFs. You can nest them. You can do data encapsulation. The whole works. An entire framework built for it. Then you can also leverage the templating inside of script. And this was always super useful for us if we're building mails or we're building some type of HTML representation in our domain models. So now you can use the expression of the 3 ticks, and then you enter tag mode. And once you go into those 3 ticks, you're in tag mode. And now anything inside of those 3 ticks will be evaluated using the template engine. So in this case, for example, I'm iterating over a collection, and I'm creating a row after each collection inside of my script, and then all that output basically goes and expresses into the outer one. So it gives you the facility now from your domain model to go into another templating language and do whatever you need to do, and then go out. All right, those are the semantics. Few differences between other languages. What are the framework capabilities? This was what we've been doing for the last 19 years. So there's a lot of things that are core, and there are a lot of things that are modules. So when we created BoxLang, we created it like our MVC framework, with a BoxLang framework defined. So the BoxLang runtime is actually separated into different types of services. And all these services, we wanted them to be available to developers. So all the API is documented and available to you. Concept of applications when you deploy to web, the concept of an asynchronous computational service, caching service, because we built caching engines for more than 10 years, the component service that we saw for the templating and tagging, data sources, so we could communicate with any database very easily, the functions, so we can provide global functions, interceptors, so we could provide event-driven programming to the developer, modules, so we could scale and build anything that's not core, and we wanted scheduling. We wanted to have scheduled tasks at the core framework and computational tasking. So the enterprise caching engine is something that we actually created for a university a long, long time ago, and we open sourced it, and this now has become part of BoxLang. So the BoxLang cache is a full cache engine, enterprise cache engine, but you can also use it as an aggregator. So you can actually adhere to our interface and communicate with Redis, with Couchbase, with Mongo, with Coffee, with whatever you want, but you're always, as a developer, going to integrate with one API. It doesn't matter which cache engine you use, you always integrate with one API. So then you can switch. Maybe in development it's a RAM cache, but maybe in production you're using Redis. Your code doesn't change. Okay? You also have the concept of object stores, so you can switch different storages. Event-driven, so you can listen when the cache starts, when the cache shuts down, when an element is inserted, when an element is removed. You have statistics as well, and the different providers that we are building and some that you can build. And this also powers all the internal caching inside of the framework as well. Now, if you're building a lot of applications, we created the concept of an application framework. So with the application framework, we basically started with the runtime, and we said, if you deploy this to a web, for example, you can have a web root, and you can have multiple sub-applications, all by convention. As long as an application.bx exists, we will treat that as a separate, isolated little application. And that isolated application was inspired by Java context. You can create an infinite segregated application, and they're also hierarchical. So a sub-application can actually listen to its parent, and so forth. It also has life cycles. You can see when an application starts, when an application ends, when a session starts, when a session ends, when the request starts, when the request ends, and many, many more. All available to you very easily to intercept. You can define data sources only for that application, and if they're not defined there, it asks the parent, hey, do you have that data source? Do you have that cache? Do you have that Java class, etc.? So everything can go and create a nice hierarchical set of applications for you. They're highly configurable and highly portable. And you can leverage them not only for web, but you can leverage them for AWS Lambdas or even for your CLI applications. Another big piece that was so important for us as developers was to have a scheduling and task framework. So you can actually write these schedulers in BoxLang, in Java, or in both. You can use them in the CLI natively, just as a replacement for cron. You don't have to deal with cron syntax. You don't have to deal with anything like that. You don't have to use Jenkins just for scheduling. You can use them in your web applications through the application BX. You can use it in Lambda, etc. You have the concept of global schedulers, so the entire runtime can be defined in your configuration, or at the application level that we were talking about, you can just create a property called this.schedulers and give it an array of paths. And you can see on the right-hand side, there's a scheduler. It's just a simple class. It gets injected at runtime with many different types of services available to you. One function called configure, how does your scheduler going to work? And then I can talk to it and I say, OK, scheduler, here's your name, here's your actual time zone, because I want you to execute on this specific time zone. And then I'm going to basically register tasks. And those tasks, I say here, my test task, call this function or lambda or whatever I want. And then every 2 seconds, but I can also say every first business day, every last business day. There's a full DSL of over 50 different types of expressions between this time of day, between this time of hour, etc. You have a full expressive syntax there for you to define your schedulers. And you can also define those schedulers dynamically. And that's something that we wanted. We wanted to be able to read something from a database and create on our schedulers. So you have tons of built-in functions available to interact with the schedulers. You can even basically say, OK, what's the status of my scheduler? And it'll give you a report of everything that's going on and how the tasks are executing. You can pause tasks. you can reset tasks, you can shut down tasks, etc. So we're even building a UI that's going to be available as a module, so you can actually be monitoring all the scheduled tasks as they're running and they're executing. With the scheduler task came about the asynchronous framework to basically sugarcoat everything that Java has been doing so well for many years now. So you have the BoxLang async framework, which starts off from the async service, where you can register all kinds of different executors that are available in the JDK, or you can actually build your own. So from virtual scheduling to scheduling tasks, cache scheduling, etc. And then we have the concept of the scheduler service that manages all these schedulers, your schedulers, and then, of course, tasks. But then we also have the box future, which is an extension to completable futures. With that, we have native virtual thread support already. So this is really important. You can create even millions of threads inside of BoxLang. Excellent for I/O operations. I would totally avoid them for CPU-intensive applications. And here's how you do it, a simple one. So here you define a runnable as a thread block, and you just say virtual equals true, and that's it. It will basically virtualize that thread, execute that in the background as a virtual thread, and you're done. You can also use our thread new BIF as well. You can pass in a runnable closure or a runnable lambda and just say virtual true as well. Or you can go into box future and actually create another BIF called runasync. And this is basically doing runasyncs with completable futures. So you can create asynchronous fluent pipelines. It's basically like threading on steroids with completable futures. By default, it runs on the fork join pool, or you can attach any executor at runtime of your choice. So you can have different methods like future new, future all. So this will actually do parallel computing for you. You can pass an array. You can pass basically any type of collection, and it will try to basically run them all in parallel for you. And then, of course, you can build beautiful expressions like run async, order service, place the order, timeout in 5 seconds, then do this, then do that, then give me a peek of what's going on, then do something else, and if there's an error, do that. And then on the bottom, I can basically present it if there's some type of value in it, or just ignore it. So you have a lot of these types of expressions available to you as a developer to make asynchronous programming easier, because it's not easy. Right, event-driven language, like I mentioned, BoxLang, we wanted this to be core, and this is how the core keeps itself very small. We basically extend everything through events. And this is also available to you as a developer. So there are ways for you to register new events and for you to listen to those events. That's pretty much it. Interceptor patterns, observer patterns, available to you in any application. Now, modularity was something that we've done for many years now with our frameworks, and we wanted to bring that into the language. So Callbox was our hierarchical MVC framework that inspired a lot of these features. It is not using OSGI. It is very lightweight. It is part of the core. It is a subset to create hierarchical class loading and isolation. Okay? You can actually see on the right-hand side a module. A module can actually be one class. With one class, you have a module called the module config, and you're done. Very, very easy. We have templates for you as developers to create these, and it taps into everything in the event lifecycle. You can write them in Java, you can write them in BoxLang, or you can write them in both. They're also executable as CLI packages. Since we can be working on the CLI, you can actually create modules to build CLI's applications. Okay? It integrates with Maven and Gradle as well. And like I said, we've already created tons of these that are open source, some that are going to be part of our subscriptions, but from AI to all types of JDBC drivers, to YAML, to password encryptions, to working with hardware and infrastructure, PDF, et cetera, et cetera. This template is available for you as developers. It's a ready-to-go template. Use it. You can even link it inside of the BoxLang home, and automatically will be available to you. This is really a way for you to extend the language. We really wanted developers to extend the language your way. So all the hooks are available for you. We have tons of demos on this, and we even created what we call a BX waffle module. which basically extends everything. The BX waffle looks awesome, and it has everything on it, and it extends everything inside of the core. And it's a great example for you to work with and start getting your hands and feet wet with BoxLang. Now, like I mentioned before, we really wanted integration. So there's even a Jython module and more for other languages. So if there are other things that are available in other languages that you want to incorporate, you can, obviously with some caveats. But the idea is for us to become a mediator of languages. To finalize a little bit of where we're going next and the tooling behind it. So this was a huge focus for us. We wanted to do the best tools for developers. So we want to make it really easy for you to get started. We have a quick installer that can be worked with any operating system. This is, for example, for Linux and Mac, but there's one for PowerShell as well. This is a really fast way for you to install BoxLang in your operating system and get up and running very quickly. We also have the JVM, which is the BoxLang version manager. Again, if you're going to be a developer working with multiple versions, this actually allows you to work with multiple versions of BoxLang, just like GNV or NVM. We have an IDE based on VS Code as a LSP, or a language server protocol, integrated. It's actually built in BoxLang. It was another runtime. Code insight, code highlighting, all kinds of docs integration. You can run code, built-in debugger. You have a whole experience where you can actually create servers. You can actually have the REPL right inside of VS Code, so you can actually be trying things out. You can manage your runtime homes from within VS Code to clear class files, manage your log files, etc. You also have a built-in version manager as well. So for example, in this project, I'm working with BoxLang 1.2. I can basically just say, hey, VS Code, I'm going to be working with this version. And now VS Code becomes 1.2. But if you open another VS Code session, you can choose another version for that session of VS Code. So this allows you to work with multiple projects with multiple versions of BoxLang. The debugger, we've done pretty much everything that other languages do, from breakpoints, not only at the operating system level, but at the web servers level. You can pause threads. You can change variables at runtime. You can do dynamic expressions to watch variables, conditional breakpoints on even dynamic expressions. And you can even do live debugging on any BoxLang-enabled server. So with that, kind of give you a little bit of what's happening in the future. So we have a 5-year roadmap, and every 5 years, we're going to reiterate. We launched this year, so that becomes an active support model for us. We have already 5 versions planned and iterating every 5 years. Every version is going to be supported with LTS for a set of years as well. So we decided to do 1 major per year. It doesn't mean that we break compatibility, but it means that it's a major release every year. Okay? 1 minor every last week of the month, and of course, patches a la carte or security when it's desired or needed. It is professional open source. That means that the BoxLang community is free and open source always under Apache 2. But there's also 2 subscriptions available if you wanted to work with us, or you believe in the project, or you want to support the project, and you want to see it further. You can also partner with us and take it wherever you want. We also are very interested in education. So we have a casting platform, and we call it the BoxLang Academy. So if you go to learn.boxlang.io, this is completely free, and these are video series, trainings, workshops, everything that we're basically building and deploying. It's going to be available free for 1 year, so developers can start learning and using our video casting and e-learning application. And then, of course, if you're working on the cloud, we already have our BoxLang cloud servers. These are available right now in the marketplaces. So if you go to AWS or Azure or Google Cloud, you will find BoxLang already available to you. So if you want to start deploying applications there, you can. And it was awesome to see the guys from Clever Cloud that are in the back here. If you want to go talk to them with Horacio, they already did it yesterday. So we sat down and we coded together, and now you have availability to do BoxLang cloud servers on Clever Cloud. So it was really awesome to see how a vendor basically in less than 2 hours was able to provide BoxLang hosting for you guys. So check them out. But with that, thank you. This was kind of an intro of what we've been working on for the last 20 months. Try it online. Everything's fully documented. We love documentation. We have our same community available with over maybe 3,000 developers already there, and all the information that you need to get started with us. But this is a community project. We're not big tech. We're just passionate developers, and we really wanted to just innovate and bring all these cool applications to everybody. So the more that we can have you guys use it and help out, that is great for us. So open to questions, but if not, thank you so much.